Hello everybody and welcome to Computational Thinking Lesson 4. So it's the same learning objectives and the same success criteria as previous lessons. So briefly, what is computational thinking? So in a nutshell, it's how we solve problems, okay? The different stages that we can solve complex problems. And these complex problems are solved using the aid of computers. Because as I've discussed before, computers can solve the problems that humans can solve, but they can do it a whole lot faster. So what is computational thinking? So it allows us to take a complex problem, understand what the problem is, and develop possible solutions. We can then present these solutions in a way that a computer, a human, or both can understand. Now, the 5 stages, so you should know these by now. Okay, so hopefully you're sitting there with your fingers and saying what stage 1 is, what stage 2 is, and so on. So hopefully you've got this right. What is it? Decomposition. Okay, now say it to the computer, the next stage, before I show it on the screen. Pattern recognition. Say the next one to the screen before I show it on the screen. Abstraction. Say the next one. Algorithm design. Now the last one. Debugging. Well done. I don't doubt you got those right. Well done. Now, what are we looking at today? Hopefully, you know what we're looking at. So we're looking at, well, for a start, let's look at the complex problems. So we know how to solve these complex problems using computational thinking, because we break the problem down into smaller problems. That is decomposition. So then what we try to do, we look at all these problems and try to recognize a pattern to help us solve them quicker. And then we try to dismiss the irrelevant details that are going to probably distract us, and we try to look at the whole picture. And then we are going to create a set of instructions to solve the smaller problems. And today we are looking at, and hopefully you've already said it, algorithm design. Okay, so what is algorithm design? Now, an algorithm, okay, now students that I've taught, we've looked at this before, more or less at the start of the year. Okay, so we use code to tell a computer what to do. Okay, because a computer doesn't think for itself. We can program it to do something called machine learning. Okay, but what it does is it follows a list of rules in order to solve a problem. So the algorithm is needed to have the steps in the right order, basically, so it can actually work properly. So like, for example, you've got your day. Now, your day is you get up in the morning, you have a shower, you get dressed into your school uniform. Well, not these days, but you know what I mean. You get dressed into your school uniform. Then what you do is you probably then have breakfast, then you'll get on a bus, come into school in the morning. When the bell goes, you go to registration. Now, imagine if you got those things mixed up. Your day's not going to go well. So, for example, you won't want to come to school in your pajamas. So algorithms. So what happens if you put on your coat before you put on your jumper? Your jumper will be on top of your coat, and that would be silly, wouldn't it? Then you write an algorithm in the order of the instructions, and it's very important. Okay? So now one way that we can write algorithms is using flowcharts. Now flowcharts, again, you've come across these before, break down a task using necessary steps. And so we can recognize what each part of that task is. There's a shape to represent each instruction. Okay, so like making a cup of tea. So in England, we do love a good cup of tea. So the start, this shape will indicate the start of an algorithm. So you fill the kettle with water. This is a process where something is happening. You switch the power on, okay? So now each of these symbols represent a process. Now, process is when something is happening, okay? So like, for example, filling the kettle with water is a process because you have to wait for it to happen. The same with switching on the power. When you switch the power on, electricity is running through the kettle. Then a decision, okay, is a diamond, okay, so this is a diamond symbol, and it has two paths. Has it happened? Has it not happened? So we check the kettle. Has the water boiled? No. Then we go back around. Has the water boiled yet? No, no. And then when the water is boiled, then you can make the cup of tea. And that is a process because you put the tea bag in, you put the water in, you wait for the tea bag to brew, and then all programs will stop because you've made the tea. You might want to add a couple more decisions in there. So for example, do you take milk? Do you have sugar? Okay. So now the next thing is pseudocode. So we can represent algorithms using either a flowchart or something called pseudocode. Now, is all pseudocode is now don't be scared by this word pseudocode, because is all pseudocode is a plan of what is going to happen. Okay, so if now pseudocode basically can be just like this, basically in English, because the idea is that you can take the plan of this program you're going to make and then you can put it into any language such as Python, JavaScript, C++, anything at all. Okay, so an output is when something appears on the screen. An input is when a user will type something in. And store is simply when the computer remembers something. And then an if and an else is dependent on what the user puts in. Okay, so what is happening here is what appears on the screen is a question. What is your name? Then the input is basically something that is allowing the user to type in their own name. Then the computer remembers the name. So then the output would be hello plus whatever name the user has typed in. Then again, the output would be a question. How old are you? Then the input would be the user typing in their age. Okay. So then to store is when the user inputs the age. Okay. And if their age is more than 70 or 70, then the output would be your age to perfection. But if they type in anything else, like 21, 13, it will say you are a spring chicken. Okay, and an example I've got of this is, sorry, hang on, I forgot to open it, so I've got to find it. Here we are. So what I've done is to show you how easy it is I just simply made it on Python. Okay, now you're slightly familiar with Python. So just going to share a new share of my screen. Here we are. So you can see here. Hang on, is it shared? Let me check. Yeah, it has. Okay, there we go. Right. So as all you can see here is basically print in Python is the output. What is your name? Name would be input. Then print would be hello. And then it will have the name that's stored. Then print, how old are you? Then input, in fact, I should have put int input, but it doesn't matter. If age is 70 or equal to 70 or greater than 70, then it says your age to perfection. So now if I run this program, okay, you're going to see it work. Let me check that it is sharing it. I don't think it is. Yeah, it is now. There we go. So I'm running the program now. So what is your name? So I'm going to type in Harry Potter. Oops, and it's not working. Oh, I see what's happened. Oh, dear, sorry, I've closed it. Oh, I've closed it. Oh dear, never mind. Okay, well, I think you get the idea anyway. Apologies that it went wrong there. Never mind. Okay, but you got the gist of it. Okay, so now what you're going to do is you're going to create a flow chart to show how you would make your favorite meal. Okay, so whatever your favorite meal is, whether your favorite meal is papas arrogadas, how do you make it? If your favorite meal is tortilla, how do you make it? And then also the next one is using pseudocode, write a program for 3 simple questions. Okay, so how you can do that is simply using this output, what is the question? Input, the user types in the answer to the question. Okay, whatever that question is, it's up to you. Okay, then you can do an if. So if question is incorrect, okay, so if question equals 2, so like say for example, output, what is the fastest car in the world? Okay, I don't know what the fastest car in the world. Okay, so input, user inputs the answer. Okay, it will store the answer. If answer equal to, and whatever the correct answer is for the fastest car in the world, output, then you can say you are correct. Anything else, incorrect. Okay, so that's how you can do that. Okay, the very best of luck to you.